Last time, we talked about the different C# data types we have to represent integers. This time, we're going to talk about the C# data types we have to represent real numbers. Before we start that conversation, here's a reminder of the Module 3 learning objectives. So, before we actually start talking about specific data types, let's talk about a problem that we have as we try to represent real numbers with a computer. The problem is that we already know n equal 2 to the b. It's also the case that the real world is a continuous domain. In other words, between 0 and 1, we have an infinite number of numbers. What that tells us, given n equal 2 to the b, is that if we're going to precisely represent every number in the real world, then we're going to need an infinite number of bits for the numbers between 0 and 1, and then another infinite number of bits for the numbers between 1 and 2, and so on. And despite the fact that memory is getting cheaper all the time, we do not have that many bits available to us. So we are making choices as we represent those real numbers. And in fact, what happens is a number of real numbers get represented with the same sequence of bits in the computer because we have some rounding. We're doing approximation rather than precise representation of those numbers. So it's important that you understand that, because when we try to represent a real number, we can't represent all real numbers with the bits we have. So some of the real numbers that exist in the real world get represented with the same sequence of bits in the computer. When we try to represent real numbers in the computer, we actually have a couple of different kinds of real numbers that we're going to represent, and we'll talk about each of those separately. First of all, we're going to talk about floating point numbers, and we get two different data types in C# for floating point numbers. We get float and we get double. And the difference between those two data types is that they use different numbers of bits for their representations. So we already know what that means. We know that floating point numbers, which use fewer bits, can represent a smaller range of numbers, and in fact can represent a smaller range of exponents as well. We're going to find, because XNA uses float almost exclusively, we're going to find that we're going to use float in large part for real number representations in the programs we write, but we have these two choices. And the operations we have available to us are as you'd expect. Let's take a look at a short program that uses floats. New project, another console application. And I'll call this one floating point numbers. Zooming in before I forget, and saving as well. We'll just save right there. And again, adding comments. So, we're going to declare a couple of different variables here. Let's say one of the areas where floating point numbers tend to be really useful is when we calculate averages. So let's actually calculate an average, and we're going to first declare variables that store the numbers we're going to use in our calculation. I'll make them both integers. So the first will be something you may have seen in the past in your gaming experience. We'll call it score. And we'll say it's 1356. That may be good, that may be bad, it depends, But there's a score, 1356. We'll also have a total seconds played, Because as gamers, we like to optimize our points per second, and so we'll have a total number of seconds played here as well. And let's make that 10,000. Notice I didn't put any commas in this literal. They don't go there, just the pure number. So I've got a score. I've got a total number of seconds played, and now I'd like to calculate how many points per second I'm actually earning in this game. So I'll say calculate and display result. And I'm going to put this result into a floating point number. So float, points per second is a good name. And the points per second are the number of points, so that's score, divided by the number of seconds. So that's total seconds played. And we'll do our output. And I will add that blank line that I always like to add. So when I run this with Control F5, oh dear, points per second is 0. And that doesn't make any sense to us, right? Points per second has got to be more than 0 because we have more than 0 points. Remember though, from last time, when we divide two integers using division, we actually get the whole number result. And because our average is less than 1 point per second, the score divided by the total seconds played is in fact 0, using integer division. What we want to do is force this to do floating point division. And so we're going to use something called a typecast that says, turn this into a float. So we need either score or total seconds played to be treated as a float for the calculation to yield a float, because we're trying to force this division operator to do a floating point division, not an integer division. So the way I can tell score to be treated as a float in the calculation is I add the word float in front of it inside parentheses, and that is a typecast. That says temporarily, right here, treat score as a float. It does not convert the score variable to a float permanently or anything like that. It's just temporary for this calculation. Once I do that, though, and I run again, I see that I now get 0.1356, which is as we expected. So this is one of those things that burns beginning programmers a lot. You heard about integer division last time, and you sort of maybe nodded your head and said, sure, I got it. And in fact, it can still come back to bite you. So we've used a float to store a floating point number. It has a decimal point in it. And so that's a good thing. It's very useful to us. And that's all we actually are going to do in code today for this lecture. So I've saved and I've closed. Now, that means, since we just talked about floats, that you probably have an in-lecture quiz to do, and of course you do. So go ahead and do that now. As I mentioned, floating point numbers, float and double, have inaccuracies in them. They are an approximation of the continuous real world of numbers, and so there is some rounding, there are some instances, many instances of multiple numbers in the real world being represented with the same sequence of bits. So we get that inaccuracy that can't be helped because n equal 2 to the b. The good news, well, it's sort of a dual-edged sword of cutting. The good news is that we have the capability to have perfect precision for numbers with decimal points. The bad news is that comes at a cost. And the cost is that we have to reduce the range of numbers we can represent. But it's important sometimes to have that perfect accuracy. When we're talking about currency, when we're talking about the stock market, if you're talking about cash register machines, we do not want to allow rounding, even for fractions of a cent, or whatever your currency is. So sometimes we need perfect accuracy. And remember, this is not tricking n equal 2 to the b. This is not magic in any way. All we're doing is reducing the range of the numbers we can represent so that we can represent with perfect precision all those numbers. And so, we have this data type in C# called decimal that gives us that perfect accuracy at the cost of a reduced range of numbers we can represent. And, this is up to 28 decimal places, so it's not like this won't work for your local cash register. But it's good to avoid the rounding. So, given that discussion about decimals, you have another in-lecture quiz. I really hope you picked the correct answer on that previous quiz. All right, so the recap for today's lecture is, just as we had a variety of C# data types we could use to represent integers, we also have a variety of data types we can use in C# to represent real numbers. And those are the 3 data types that we talked about today. They're also value types. Remember, the memory location is the bits at the memory location are actually the value of the variable. But we still have a few more value types to talk about in addition to the numeric types that we've talked about last time and this time. So for the next lecture, we will finish off Module 3 by talking about the other value types that are available to us in C#.